Subnetting. It is the single biggest reason students fail their networking exams. It is the gatekeeper. When you look at it in a textbook, it looks like scary, complex math. But I have a secret for you. It isn't math. It is just logic. Most professors teach this completely backward. They tell you to memorize a chart, or they give you magic numbers to calculate answers quickly. That works great for a multiple choice quiz, but it fails in the real world. If you just memorize, you don't actually know what is happening. Today we are going to fix that. We are not going to memorize a single thing. We are going to look under the hood and see how the engine actually works. Once you see the logic, you will never be confused by an IP address again. Forget about computers and binary for a second. Let's start with something physical. Let's start with a letter. Imagine you want to mail a letter to your best friend. They live at number 10, Main Street. Now think about that address. It actually has two completely different parts mashed together. First, you have Main Street. That is the neighborhood. That is the street name. Everyone who lives on that street shares that name. The neighbor to the right is on Main Street. It groups them all together. Then you have the number, 10. That is the specific house. That number is unique to your friend. If the neighbor was also number 10, the mailman would go crazy. He wouldn't know where to put the letter. So you need both. You need the group name, and you need the specific unique ID. This is exactly how computer networking works. We just use different words for it. We don't say street name, we call it the network ID. We don't say house number, we call it the host ID. Every IP address you have ever seen is just a street name and a house number pasted together. Let's look at a real example. Look at this address, 192.168.1.5. Here's the million-dollar question. Where is the line? Which part of those numbers is the street, and which part is the house? Is the street just 192? Or is the street 192.168.1? The answer is, you don't know. You cannot know. If I just give you an IP address by itself, it is impossible to tell where the network ends and the host begins. We need a tool to draw the line for us. We need a divider. That divider is called the Subnet Mask. It literally masks or covers up the network part so we can see who the hosts are. You have seen this number 1,000 times before. It usually looks like this, 255.255.255.0. To a human, that looks like a random string of numbers, but computers don't think in decimal numbers like we do. They think in switches, on and off, 1 and 0, binary. To really understand this, we have to translate it into the computer's language. In binary, the number 255 is just 8 ones in a row. It is like turning on 8 light switches at the same time. So, when a computer sees that subnet mask, it actually sees this, 24 ones, followed by 8 zeros. This pattern is the key to the entire universe of networking. It is a set of instructions. The ones are the computer saying, this part is the street name. Do not touch this. It is locked. The zeros are the computer saying, this part is the house number. You can change this. This is available for hosts. Let's verify this. Let's stack our IP address on top of our mask. Look at the mask on the bottom line. Where do the ones stop and the zeros begin? Right there. After the third group of numbers, that line is the separator. Because the mask has ones underneath the first 3 sections, those 3 sections are locked. They are the network. So, our street name is 192.168.1. Because the last section has zeros, that is our house number. So, our host ID is simply 5. This means any computer that starts with 192.168.1 is living in the same building. They are neighbors. They can send data to each other instantly without leaving the building. But if I change a computer's address to 192.168.50.5, the street name has changed. It is not .1 anymore. It is .50. That computer is now in a different building down the road. It cannot talk to the first computer unless we use a router to carry the message between them. That is all subnetting is. It is using a mask of ones and zeros to decide how big the street is. Now, network engineers are incredibly lazy people. We hate typing 255.255 over and over again. Takes too long. So we invented a shortcut called CIDR notation. Remember our binary mask? How many ones did it have at the start? It had 24 of them. So instead of writing the whole thing, we just write /24. When you see /24, it literally just means my subnet mask has 24 ones. If you see /8, it means my subnet mask has 8 ones. It is just a count of the ones. That's it. Now you might be thinking, Mentor, this is actually pretty easy. That's because I gave you the easy numbers. We cut the line perfectly between the groups. But what happens if I give you a /25? A /25 means the line doesn't fall nicely between the numbers. It cuts right through the middle of the last number. This is where the logic gets tricky. This is where the math gets messy. And this is exactly where most students fail their exams. But don't worry, in the next video, we are going to take this foundation and we are going to crush that problem too. Your homework for today: open your command prompt, type ipconfig, and find your subnet mask. Convert it to binary, find the line. Once you see the ones and zeros, you understand the matrix. I'm the CS Mentor, thanks for watching, and I will see you in the next video.